task 7.
Sorry, your voice is like very cutting out. Not really, no.
Now?
Yeah, alright, that's good.
Okay. So for task 7, basically asking you to get your. Can you show me your
Yep. Oh,
graph,
sure.
the final one, like the difference between pre and post?
I did it here. 1 second. I got this here. Is that the one you're talking about? This is the post and
Oh
the
yeah,
pre.
no, not that one, not that one. I'm looking for your. How do I say it? So you're developing one subcatchment, right?
Yep.
Yeah, I'm looking for that subcatchment storm hydrograph. That's basically the post hydrograph. Yep.
So this one?
But this is the total, right? It's the total of all four
Yeah.
of them.
Oh, do you want the inflow and outflow of the other one then? This one?
Mm,
Can you show me which
no.
one you're talking
Isn't
about in
isn't
yours?
this isn't this task 5, the inflow outflow thing which you've done here?
Yeah, but you had to redo it for task 6 again.
Why?
Because we're developing a new one. When we develop it, we have new outflow. We have new inflow because we guessed the numbers in between. So it means we have a new outflow as well, doesn't it?
What do you tell me about this in your text, but I don't get this. Like, why are you routing it again if the water is not flowing? Are you developing subcatchment A? That's my question.
I'm developing the same subcatchment that I routed before.
Oh, okay. Then it's all good. Okay.
Yeah.
But then I guess you okay.
Do you think
Yeah,
it's
yeah,
wrong?
yeah.
I don't
No,
have to
it's
do
not
that?
wrong. No, no. If you're developing the same subcatchment as the one you've routed, then it's fine. Then you have to route it again.
Yeah.
If you're not developing that, then you don't have to. So okay.
Sure.
If you have your outflow now, basically that's
Yeah.
so did you get the rainfall excess and everything? Like, did you do
Yep.
the yeah?
I did that over here.
Okay.
I
So
got the rainfall excess, the new one here, and then I
yeah,
did the same
perfect.
part again. This
Okay,
thing here.
perfect. Okay, so that was your info. Then you routed it, right?
Yeah.
Okay, great. 8 minute रुक जा. देखो 1 minute. So after this, what you do is you make a graph comparing the post-development value for the catchment and the pre-development value. The pre-development will come basically from task 5. Like, yeah,
Okay, so the
yeah. You
pre-develop.
compare the outflow for this one and the outflow for the new one, the
Are we gonna be
developed one.
using this part here, the combination for both of them, or
The
the in?
combination for no, I just need it for the catchment, not the complete, not at the outlet response, just for the
Okay.
catchment.
Yeah, so that means it's this one here, just the outflow and inflow.
Yep. Okay, yeah,
Alright.
this inflow is basically. Yep. Did you do it there? What's this graph?
This graph is just the inflow and the outflow.
Mhm. Oh, this graph is what I actually need is so my pre-development outflow, what it's coming out.
Do you wanna show me from yours? That way.
Like I didn't do it for the same catchment, so I didn't have to route it twice.
Yeah.
I can show you.
Alright.
Okay, so sorry. This. Okay, so over here, you did all this part. You did this.
Yeah.
Okay, then you even did. This is I'm doing it for my catchment C. That's
Yeah.
my new rainfall excess and everything. That's my storm hydrograph. Okay.
Yeah.
Then what I'm doing is I have my pre-development from my storm hydrograph. This pre-development is basically my whatever I got in my task number 4 when I was doing storm hydrograph for catchment C. And
Okay.
this post-development is basically this storm hydrograph. These values.
For catchment C as well, yeah.
Catchment C after
Okay.
developing it. Yeah.
Yep.
After I get these two, I'm plotting a graph like this one.
Yep.
So now the point, task 7 basically is okay. So it depends where you're going to put your reservoir.
Yep.
Okay, and it's very possible that when you plot the pre-development and post-development graph for your for the subcatchment you're developing, or even at the outlet, the possibility is you will get your post-development graph to be higher than your pre-development one.
Yep. So is your
Yes,
one higher or lower?
it's higher, yeah, because my
Okay.
orange one is the post-development one.
Yep.
If I want to show you a clear picture, yeah, this one. Yeah. So
Yeah.
what we do is we now the task 7 is basically about knowing the volume of your reservoir, like how much volume would you construct your reservoir for.
Okay.
So basically in our case we had two peaks, right?
Yeah.
I have two peaks, but I'm not going to consider the second one because that would give me a really big value for my that would give me a really big volume for my reservoir. So we just
Yeah.
consider the first peak. Surendra said that in our Q&A.
Yeah.
So what we do is you take a line, and wherever the peak of the pre-development, yeah, see,
Yeah.
is touching the post-development, you take a line over there, and then you can so where your post-development starts, you draw a line up till that point, and then
Yeah.
I have to calculate this area, this part, whatever's under this orange graph and this diagonal.
Sorry. Can you repeat that last part? What area are you
Uh,
calculating?
I can show you a bit of it. Basically, what area you have to calculate. Can you still see my screen? No, right?
No.
Uh, Screen. Okay. Okay, I'll just have to see where it is. So many documents.
Yeah. No, I can imagine.
Shit.
Oh my god.
Should be in here. Mm, okay, I don't know which is the correct one, but I can. So, okay, no, it's not this one. Yeah, can you see? This is the
Yeah.
area that we have to calculate.
Okay.
Like the one from the post development curve and the diagonal line. That's the only one we have to calculate.
Mm. And how did you calculate that area?
So what you do is, you know, the curves, you know, your points up to this point, right? You'll
Yeah.
know, yeah, you calculate the area under the curve between both these points.
Yeah.
Yeah, the blue one and the orange one. Okay, and so if you deduct them, so you will get the area between, you know, this thingy between the two curves,
Ah, okay. So
basically.
I first do the area under the blue one and then
Yeah, under
under the
the
orange one, and then
orange
I
one, yeah.
minus them. Okay.
Yes, you deduct them. So basically, and then you remove this orange, the triangular part.
Yeah. Makes
But
sense.
it's easy by using because you know the base, right? Base is going to
Yeah.
be 660 minus 60,
Yeah.
and then height is going to be whatever your peak height was over here. Like mine was 11.280,
Yeah.
so that's my height. So half into base into height, and you get area for this, and you just deduct that from the whole thing,
Yeah.
and that's
Okay.
it. Okay.
Yeah.
After that, so after you get your area, you'll get a number, like let's say 50k 50,200, something like that.
Yeah.
So you're supposed to increase it by 1.1%, as we are not taking the complete area under the curve, we're just taking it up till the first peak.
All right.
So I'm just going to multiply that with by 1.1, and that would be my volume of the reservoir.
Okay. So we're multiplying the area by 1.1 or the peak?
No, the volume which you get, the area under the curve,
Okay.
the volume, basically. Because see, what this graph is saying is, after development, your peak is increasing by this much, which basically
Yeah.
means that it's flooding my area, my catchment.
Yeah.
That is one of the reasons we're developing a reservoir, so that we can store our water there. When because of the development, the graph is basically going to increase this way. So I'm going to develop it, and where am I going to store this extra water? So
Yeah.
that's why we are building up a reservoir.
All right. Makes sense.
Yeah,
So the step is to find the area, and then after you find the area, you multiply it by 1.1
1.1. Yep,
to find the volume. Yeah.
volume of so basically what this 1.1 is, we're getting this curve, like this calculation is giving us the volume of reservoir, but
Yeah.
for safety reasons we're increasing it by 10%,
Yep. Makes
because
sense.
as we're not considering the complete area under the curve, right? We're just doing
Yep.
it until up to the first peak.
Yep.
That's
Makes
why we
sense.
increase it by 10%.
Yep. Just to be safe. Yeah.
Yeah, so you have the volume of your reservoir.
Yeah.
Okay, and then um okay, this is then starts reservoir routing, then actually starts the calculations, and trust me, it's way worse than what we did after task 6.
Is
Actually,
it
each
actually?
yeah, each task it's just worse and worse and worse. That's it,
Fuck
it's
me
not
dead.
getting any better.
Oh my god.
So once you get your area, like under the curve thing, the complete thing,
Yeah.
um I can actually, it's better to show it this way, right? Can you see the
That's why
whiteboard?
you're always like it's tiring to tell people over and over again
It's
because it
and
takes you so long.
it's yeah, and it's more difficult when people don't understand the concept, like they
Yeah,
don't know what they're doing.
yeah, like yeah, I
Because
get you.
it's so difficult to explain. It's going to be difficult for me to explain it to Prithvi because he
Mm,
doesn't know what this shit is, like what is happening.
yeah, true.
Yeah. So in reservoir routing,
Yeah.
there's a table. Actually, wait. I actually have everything open in my laptop. I've not closed a single window.
Yeah. Nah, I mean you were just doing your assessment. I just finished my test, but you were doing the group assessment as well, yeah?
What group assessment?
For your other unit, the
Oh
presentation
yeah, yeah,
thing.
yeah, yeah.
Yeah.
Yes, it's on right now. Hamad and Prithvi are working on it. I'm like,
Mm.
please, can you guys do it? I'm just gonna finish this.
Fair enough, thank you.
Um, okay. Actually, if you go to views, there's a formula given for this reservoir routing. Okay, there's a table
Yeah,
where you have to plot your time first, then comes in. Sorry, in plus 1, and there are a few more tables. So how do you
yeah,
plot it? Okay, but then for reservoir routing, the first thing we do is we need to plot first. This graph is basically depth. Okay,
yeah,
in the lecture notes it might be written as elevation, one and the same thing. Water
yeah,
elevation. Okay, so depth versus discharge is the first one, or no, storage volume. Okay, it might be written as storage. So
yeah.
first you get depth versus volume graph. Next is
And what's my depth? Where do I get depth from? Do you
yeah,
know?
I'm gonna tell
Oh
you
yeah?
that. Yeah,
Alright.
next you get is depth versus q.
Yeah,
Okay, once you get these two, v is basically denoted as s, storage directly.
yeah.
Yeah, they don't write as v. Okay, once you get that, the final thing is to construct your graph, which you basically need the third one, which is q. You
Yeah,
already have q. Okay, this q is going to come here.
yeah,
Q versus 2s divided by delta t plus q. Your s is going to come from here. You know your delta t. Our delta t is 5 minutes. Yeah,
yeah.
our intervals, and you already have q. So then you get these two tables and you plot them. So where's your v and everything going to
Sorry,
come
so it's
from?
2s over delta t plus q
Plus
at the
q.
bottom. I
Yes.
and do you get it for each point? Like for each point of
Each point.
s
Yep.
and
Each
each
point of s. Yeah.
okay.
So what you do is,
And
you
delta
know
t
the
is that 15 minutes or is that for each
5 minutes.
different
Take it
5
as
minutes?
5 minutes. Yeah. Because I
Yeah.
did for 15 and I had to redo it.
Okay.
I did the complete. I don't want you guys to repeat it.
Okay.
It's way too much. So
All
just
right.
take delta t is 5 minutes.
Yeah.
Okay. The next step is, so basically now you know the volume of your reservoir. It's your decision as an engineer to decide the shape of the reservoir.
Yeah.
Okay, you're allowed to assume anything, like assume it's a triangular, a rectangular section, a trapezoidal section, or anything. Okay,
Yeah.
that's the way. That's where you start. You get your v. What you're gonna do is you're gonna plot a table called depth. The next would be storage, basically v, volume. Okay,
Yeah.
if let's say you're considering um, a rectangular reservoir,
Yeah.
yeah, you will start assuming by saying the length of my reservoir is 50 and the width, basically in the third direction, yeah,
Yeah.
that width is going to be
So are you making these numbers up?
up. Yes, I'm making these numbers up.
And I'm gonna make these numbers up as
Yep,
well.
yep.
All right.
Okay, so let's say you're taking your width as even width as 50. Okay,
Yeah.
so you're assuming, you start by saying that I'm assuming the width and what do you say, the length and width of my reservoir as 50 by 50. And
Yeah.
then for the depth thing, what you do is you start by putting up numbers: 0, 0.5, 1, 1.5, and so on.
Yeah.
Then you can calculate your volume, because you know you've assumed L and B, and volume is basically L into B into H. Yeah,
Yeah. L into
you've
B.
assumed these, and D basically you're getting from these values.
Yep.
So you'll start getting a number of volumes, okay?
So wait, sorry. So L will be our length, our B will be our breadth,
Yep.
and our H, what would that be? Would that be our depth?
Yeah, that's the D. Yeah.
Yeah.
You start putting up a numbers, like put it in this way: 0, 0.5, 1,
Yeah.
1.5. Okay, and then you'll, because you've assumed your L and B now, you'll start getting numbers for your volume.
Okay.
Okay, you continue. See, you let's say you got 30 over here, then you get 20, like let's say 200, then 2000, something like that, and maybe around 10 meters or 12 meters or something. Let's say your volume comes out to be 50K. Yeah. And then
Is
at
that
12,
the sum or is that the last number?
the last number after 1.1.
And how many numbers do we do, like, until?
Yeah, so that's what I'm saying. So let's assume when you're doing for 12 meters, when you're considering D as 12 meters, you get a value called 50, you get value 52K. So now you know that your volume is going to lie somewhere between 11 and 12. And then you can calculate the depth by interpolating it. That's going to be the depth of your reservoir.
Okay.
Do you get that's
I don't get that last part. How do you calculate the depth of that last part? It's just by.
Okay, see. So you start by so you've considered L.
Yeah.
You've considered B.
Yeah.
To draw the graph of depth versus storage. So I need my D and I need storage. Correct? I'm starting to consider my D as 0. Next would be 0.5.
Yeah.
1,
1.5, and then you keep
and
going
so
to
on.
12.
I keep going. Okay, and then when you put for this, you can directly put a formula: L into B into H.
Yeah, and you assume
When
L
you put
is
this,
50 and B
E
is
is
50.
also 50, and H for this one, H is going to be 0. So you'll get 0 probably. Then for the second one, 15 to 15 to 0.5, you'll get some number.
Yeah.
Okay. Let's assume for the moment that when you did your your reservoir volume calculations from the graph.
Yeah.
Let's say you got 52,000.
All right.
You want to know for this 52,000, what is your depth?
Okay, so you keep going down until you get
Keep
something
going,
close
until
to
you get something
52,000.
bigger than this,
And then you
then
find out where your
interpolate
depth
it.
is.
Yep, correct.
Yeah. Okay.
That's your depth. And once you get that, you can plot the graph, and it's probably going to be a straight line, because they are related to each other. I mean, proportionate to each other. Because it's going to be a straight line then. So then you're done with the first graph. Okay.
All right, mad.
Next is basically depth versus discharge.
Yeah.
Okay. Now it's about now, because now you know your volume, right?
Yeah, so we can just multiply it by delta T multiplied. So we can just multiply it by 5 times by 5, right? By 5 times 60, because then that's the delta T in every 5-minute interval, and then it's seconds. So you've got seconds times by meters cubed per second. Sorry. No, sorry. Can't you just divide it by 60 times 5, the volume that you had before?
You can, but the question that will arise is, a reservoir is something which is what do you say? It's basically a concrete structure.
Yeah.
But then how are you going to get that water, the water which is getting stored inside the reservoir, out of the reservoir?
True. Yeah.
Yeah. So for that, if you go through his slides, okay, there's a table over there when he's explaining about reservoir routing.
Yeah.
So when you have your depth, now let's say you have your depth to be 12 meters, 12.5, okay?
Yeah.
And you have your length and breadth and everything. Now when I'm drawing my reservoir, let's say something like this. Okay, what is going to flow? What we do is basically the discharge. What we have to know after developing a reservoir is either by providing a weir at the top from where water can directly flow, or by providing a pipe or orifice at the bottom. Orifice is basically a circular structure, a really small circular structure.
Yeah.
And pipe, or either by providing a pipe at the bottom or a spillway at the top.
Yeah.
A spillway or something. So whatever, because spillway has Q formula. This orifice or pipe is going to have a Q formula.
Mm-hmm.
So it's so okay. What I suggest you doing is you finish up with, you get your volume, okay.
Yep.
You
So
consider a
that's from
structure.
the part before.
Yes, you get the
Yep.
pre and post, okay. Your post will be higher than your pre, get the volume, and then you finish up, you get this table, and then I'll explain you about the spillway, because I know you'll be confused if I do it right now.
All right. So
You finish up, like you get the volume of the reservoir, okay.
yeah.
Volume of the reservoir, and then after that plot, consider any section, okay.
Yeah.
Assume your L and B and everything, and plot this D versus volume graph, and once you're done with that, let me know, I'll explain this part.
All right. Can you show me the um what you did like on the Excel sheet again for
Yeah,
that
sure.
part? So
Oh shit, sorry. Excel is this one, yep. Okay, so I assumed my structure to be a trapezoidal section,
yeah.
because you know how we've always studied and how they say that trapezoidal is the best hydraulic section to select.
Yeah, from hydraulics.
Yes,
Yeah.
from hydraulic. Yeah, so I assumed it to be trapezoidal. This was my area,
Yeah.
72.362. Yeah, sorry, my volume. Okay,
Yeah.
after increasing it by 10%. So I
Makes
assumed
sense.
it to be trapezoidal, and I assumed everything is an assumption at the moment.
What the fuck is the point of this
Yeah,
unit?
I'm designing it, right, so I
Yeah.
can assume whatever I want. So I assumed my slope to be 1:4,
Yeah.
and then I made my square base at the bottom, like 50 by 50.
Yeah.
Yeah, and then I calculated my volume, storage by volume.
All right. And you kept going until you got a number close
Yeah,
to
something
that number,
bigger
and then
than,
in
yeah, I
between
actually
them.
went till 15 meters,
Yeah.
but then mine was 72. So I
Yeah.
what do you
In
say?
between.
Yeah, so I
Yeah.
got
You.
13.77.
Yeah. So you did. You said like you did 70. You did 70200 divided by 742, and then you multiplied it by the difference in.
Yes, yeah. So
Okay,
I
and
got,
you get the
my value
exact
was
time.
basically, yeah,
Yeah.
13.77. Yep.
Yeah. Okay, makes sense. Easy.
Yeah, 13.77 meters.
Yeah. And then before you continue as well, for task 6,
Hmm.
my reservoir routing thing, I don't need it really, do I? Or should, or the one I did, not my reservoir, sorry, my
Channel
channel
routing.
routing. Do I need
Okay,
that or
so
no?
what I'm saying is,
Like for my channel 6, all I have to like for that part specifically, your one, I have to.
you're doing catchment C, right?
Yep.
So what I guess what you did was you are developing catchment, this catchment, right?
Yep.
Yeah. So that's why if you are developing a subcatchment, then you'll have to route it. But
Yep.
I think you have to route it after you're done, by after you're done developing it. Don't route it right now. So you have your rainfall excess and everything, right?
Yep.
So the new values which you get are basically post development values.
Okay.
Okay. Once you get that, compare your results of pre and post, and that's going to
Okay.
give you a graph. What I did was, and it's your decision. So if you want to provide a reservoir at the outlet, over here,
Yeah.
okay, or over here somewhere, because what I'm doing is I am developing this catchment,
Yeah.
this one. So
So
I'm
do you think I should like redevelop my catchment for it to be that one instead of the one I did? Because the one I did, I had to route and everything, but I won't be using the routing thing again, would I? Like it's just there for me to talk about in my report.
Yes. So what I would suggest is, like, if you have time and if you want to do it, maybe develop either this one or that one, because then you don't have to route it and it won't create issues like
Yeah.
what do you say, errors or something, because
Yeah.
it's confusing, that you get your post development one, and then if you don't route it, it's going to be wrong.
Mm,
So
yeah.
if,
True.
because if you feel you can finish it up sooner, like, because now I guess now you know how to do it, right?
Yeah.
So what you can do is either, that's why I developed, because when Surendra was explaining this project brief, his was uh, for post development. It's up to you guys to make a wise decision.
Mm,
So I was discussing, and then a friend of mine, she did this one, and then she was like, I had to route it. So I was like, okay, I'm not gonna, because we can select any catchment,
yeah.
and what matters is what is coming out at the outlet at the end.
Yeah.
So that's why I choose this one, because I don't have to route it then.
Okay. So when you do this one, can you go onto your Excel sheet now?
Yeah.
When you did that one, So for task 5, it's simple. Like I know the steps how to route it for task 6. Sorry, I mean not
Mm.
how to do task 6, but then in task 7 when I can sorry in
Yeah.
task 6 when I draw the shit, what am I drawing exactly? Like the new outflow with the I mean the new inflow. You know that task 4 ending with the old one, and you just compare them,
Yep.
right?
Yeah. See, this is my postal. So I got a value for my, so this value what I get after doing my storm hydrograph thing for the post development part with the new
Yeah.
rainfall excess is basically storm hydrograph post development for that catchment. And the pre development one is basically what we did in task 4.
Yeah.
So if you're developing, let's say the B catchment, the smaller one at the right corner,
Yeah.
yeah. So after you get all your rainfall excess and everything, and you do the storm hydrograph part,
Yeah.
and whatever you get, but after the new rainfall excess is basically your post development value, and this pre development you take it from task 4 storm hydrograph.
Yeah. All right.
That's it, and then you can get you can do this graph thing.
Okay, and with this graph thing, just quickly, what to find the area, it was half B, which is gonna be up like 60 to 660,
Mm-hmm.
right?
Yeah,
Does
whatever your
that
peak
sound
is,
good?
actually your peak
Yeah,
might be at a different point.
yeah. So
Yeah.
it'll be just for your one. Say, how did you calculate it? Like exactly for your one? Can I like write it down so I can
Yes.
follow the?
Yes. Or what you can do is first get your area under the orange curve, like
Yep.
basically not the orange, basically where the, okay, this picture is better actually. Yeah, up to this curve, where it's meeting. See, once you draw these lines,
Yep.
okay, this blue thing is not in the picture anymore.
Yep.
We're not worried about the, all we needed the pre-development one was to get its peak and where that peak is
Oh, okay.
intersecting here. So don't look at um the blue one at all at the moment.
Yeah.
Okay, what I am going to do is, because I know this point now, right, I can calculate my area under the curve. What I'll get this thing, I'll get this complete area from this part. Okay, I'll get this thing, this area.
Okay.
Once you how we calculate area under the curve, right? You can do
Uh.
trapezoidal or any method you want to.
Okay.
Yeah. So
Yep.
I get this. I'm gonna get this complete thing, but I only need this part.
Yep.
Um,
Makes sense.
I only need this much.
Ah, okay, yes, yes.
I only need this much. So
Yeah,
what
so you
after?
find the
Yeah.
area of the bottom one and then you minus them from each
Mm,
other and you'll have what's inside.
correct. I then just remove this triangular part.
Okay.
Yeah.
So all you'll need basically is what's in between.
All you
Um.
need is, yes, this black thing, the complete thing. But all, yeah, at the end, all you need is this part.
Okay.
This green thing. Sorry, this green
Yeah,
part.
yeah, I get it. Yeah.
That's it.
All right, mad.
That's do like you finish this up, because if I tell you about, because task 7 is bit lengthy,
Mm,
you finish that up, get your reservoir volume and stuff, and do the
yeah.
first part. Select a section for your reservoir, and then I'll tell you the remaining parts.
Are you free to show me tomorrow about
Yeah, yeah,
or?
100%. I'm free tomorrow. Yeah.
Alright, if you want, then instead of like having to show me and then show like Prithwa or something, I can wait until you teach him as well, unless he does it very slowly and then, like,
Okay, I'll let you know in the morning.
yeah, just let me
Yeah.
know what you want to do. Alright.
And let me, when you finish up, let me know, because I guess it'll hardly take 20, 30, like 20 minutes to explain.
Yeah.
Yeah.
Oh, okay. So it won't take
Yeah.
long to explain the other one after I finish this?
Sorry.
It won't take long to explain like the other stuff for task 7 after this? Or no?
Um, no, actually, because for task 7, there's one calculation which is not explainable at all. You'll have to watch his video. That's what I did,
Yeah.
and I saw another video on YouTube. I'll send you, because that's what I did. I'm sending that video to everyone who's asking me how to do, because it's not
Yeah.
possible to explain that. It's very complicated,
Mm,
and you can't drag it on Excel directly.
yeah.
So I'll
You
send
know
you
what
that
I
video.
might do? Like I might finish off this and then try to do that, and I'm just gonna submit it like that. I don't care anymore. Just
That's
take.
what everybody is saying. Everybody's like, and now we don't care anymore. I'm just gonna submit whatever I have,
Yeah,
because we've done enough for this project already.
yeah. Like fuck. What is this? It's a
And
joke.
it's too much for one
Yeah.
person.
This
It
is meant
doesn't
to be a
need.
group one, and he's making.
Yes, and he said that he's deducted parts so that it becomes a project for an individual person, but this is not something an individual person does.
Yeah,
It's
100%.
actually too
It's
much.
making me like get scared to do water in water for the sub major.
No, it's actually I enjoyed doing this because after doing this project, the
Yeah.
um the lecture parts make sense to me
Oh
because I
yeah.
know what's happening.
Yeah.
Because when
True.
he was doing the lectures, I had no clue what's initial
Yeah. It's just
losses,
like
what's
yeah.
constant losses.
You're just timesing random stuff and
Yes,
getting
but
the
now
answer.
I'm actually understanding everything.
Yeah. Fair
So
enough.
that's pretty good.
All right. Well, thanks for your help. I'll try to
No
get
worries.
that done, and we'll see how it goes from there.
Yep.
Appreciate it, but sorry for wasting your time. You probably
No,
have
no
assessments and
worries. No,
shit.
no,
Alright,
not at all. Yeah, let me know when you finish up.
will do. Thank you so much. Jamie was meant to be here, but he fell asleep. The cunt.
Oh, he's an early sleeper.
Yeah.
Awesome. No worries.
Alright. Thank you
See
so much.
ya.
Appreciate it
No
again.
problem. No worries. See
Have
ya,
a good
bro.
one.
See
Bye.
ya.